All right, so the purpose of this video is to run through polynomial long division. And we talked about long division with numbers today in class, and we said it was a 4-step algorithm. You divide, multiply, subtract, and bring down. So what I'm going to show you is how this works with polynomial division, and it works pretty much like the number division with a couple of adaptations. So the first thing we're going to do is we are going to divide first term by first term. Now what that means is the first term in my divisor, x cubed, is going to be divided by the first term in my dividend. I did that the wrong way. First term in my dividend, x cubed, is going to be divided by my first term in my divisor, which is x. So x cubed divided by x is x squared. That's the number that's going to go on top of the division sign, the little house. So that's just fine. It's just like the first thing that we did with the numbers. The next step is we're going to multiply that result, the thing that we put on top, by the entire divisor. So this x squared is going to be multiplied by all of x plus 3. So when I multiply x squared times x plus 3, I get x cubed plus 3x squared. That's what's going to go underneath. Then I'm going to subtract just like I did in long division with numbers. Now when I subtract, it's easy because there's multiple terms here and I'm subtracting. To forget, I need to subtract both things. So I tend to put parentheses around everything. So x cubed minus x cubed goes away. And that is one of the things that should always happen in this. This little space right here should end up being blank because we chose something to put here that when it multiplies by this would give me the same thing. That's why it should subtract away. So you know you're doing the right stuff. And then 6x squared minus 3x squared is 3x squared. Now I'm going to bring down my next term and repeat the process. So divide first terms. This time it'll be 3x squared divided by x, and that will give me 3x, positive 3x, so that would go up there. I'm going to multiply that by the entire divisor, which is x plus 3. So that would be 3x squared plus 9x. That goes underneath. I'm going to subtract that. 3x squared minus 3x squared goes away. That should always be the case. Negative 5x minus 9x is negative 14x. And then I'm going to bring down the next term. I still can go on, so do it again. Divide first term by first term. So that's negative 14. That's what goes on top here. Multiply negative 14 times the entire divisor. So it'd be negative 14x minus 42. That goes underneath. Subtract away. That should all, left my x off. Subtract away, that should always go away, and it does. 4 minus negative 42 is a positive 46. Now when I go to bring down the next term, I don't have anything I can bring down. So that means I hit the end of my algorithm, and my answer is the quotient on top, x squared plus 3x minus 14. And this 46 is my remainder. So I'm going to add that as 46 over the divisor, x plus 3. That's like making this thing into a mixed number. Remember, when you have a mixed number, it's typically the whole number plus the fraction. We just don't write the plus. I actually have to write the plus out here. So this would be the answer to that division problem. We'll do another example in the next video. All right, so here's another long division problem, but this time we started with it as a fraction, no big deal. So we're going to write this in the house notation. Remember, the thing on top of the fraction, which is the numerator, is the same thing as the dividend. It's the thing that goes under the house. But before we write this, I'm going to tell you something that will make your life a lot easier if you pay attention to it. Do you notice how when I look at the powers on the thing that's in the numerator, they go x cubed, x squared, and then they skip an x and go to 3? When we're doing long division, if you ever see powers that are skipped, it's really useful to insert a placeholder so everything lines up when we go to do the subtraction step. So when I write this numerator underneath here, I'm going to write x to the third, 5x squared. I'm missing an x term, So I'm going to say I have 0 x's and actually make sure that's there and then put the minus 3. And I'm going to do the same thing with the divisor. It goes x squared. I'm missing an x term and then minus 2. So now I'm going to do my algorithm. And when I do it, because I inserted these 0 terms, things should line up properly for me. So divide first terms, x cubed divided by x squared, which is x, that goes on top. Multiply the x times the entire divisor, so x times x squared is x cubed. X times 0x is 0x squared. And yes, I could leave it as just 0, but I like keeping the term type there so you can see that like terms are actually lining up. And x times negative 2 is negative 2x. I'm going to subtract that. X cubed minus x cubed is nothing. That should always be the blank spot because of the way we choose the thing that goes on top of the house. 5x squared minus 0x squared is 5x squared. And 0x minus negative 2x is plus 2x. So notice how my divisor has 3 terms in it, and the thing that's down here has only 2. So I'm going to bring down a term. If I had only 1 term here, I would bring down the next 2, so it kind of makes everything alignable. And then I'm going to repeat the algorithm again. 5x squared divided by x squared is 5. That's a positive 5. Multiply 5 times the entire divisor. I'm going to subtract. 5x squared minus 5x squared goes away, as it always should. 2x minus 0x, negative 3 minus negative 10 is a 7. I have nothing else to bring down, so this means I've got a remainder. Notice too, my remainder, the power on it, the highest power is a 1, and the highest power of my divisor is x squared. That will typically always happen with your remainder. That will have a power smaller than the highest power on your divisor. So that means that my answer on this problem then is x plus 5 plus the remainder over the divisor. Now, if you happen to put, the 0x and the x squared minus 2, that's fine, but it's not necessary once you're writing your answer.